Hello everyone. In this video, we want to see in general how do we do partial fraction decomposition. So far, we have considered the cases. But first of all, we have to first make sure that the degree of the denominator is bigger than equal to degree of the numerator. So degree of the numerator must be less than degree of. That's when we can start partial fraction, no matter what is going on in the denominator. But then we learned that if the denominator has a has a factorization of a linear term, so like this, and then a2x plus b2, and all of them, sorry, this must be product, and all of them have power 1. So that's what we call distinct linear factors. Distinct linear factors. So what do we do in these cases? For each one of these ones, we add one partial fraction. For the first one, we add a1x plus b1 in the denominator. In the numerator, we put just one constant. We don't know what yet. For the second one, we put a2x plus b2. Then we put a2 there. And then for the last one, anx plus bn. This is a. So then we fix the form of the decomposition, form of the partial fraction decomposition. So that's the form, and then set it equal to pq, and from that point on, I assume that you have done some work and you know what to do. So you make one common denominator and then equate the numerators to with each other, and you find set of equations, solve those ones, and find these constants, and that's how it works. But as you can see, fixing the form is the key point. From that point on, everything is just machine can do that. Yes. Now, what if we have a factor which is linear, but it has power? So it's, let's say it says ax plus b to the power some j. J is bigger than 1. Okay, so ax 2x plus 1 to the power 10, or 2x plus 1 to the power 3. Okay, in that case, this is interesting. You have to listen here. This is important. You don't add, for such a factor, you don't add one partial fraction. You add j partial fractions. What are the partial fractions you add? Well, you start with ax plus b to the power j, and then in the numerator, well, I don't know what to put yet. Just constant. Put it there, and we will do the same works as before. Then make one less power and consider that partial fraction as well. Make one less and then get up to point that, well, like ax plus b to the power 2, and then a1 over ax plus b just itself. So for a repeated factor, or a factor, linear factor with power, we add, before, you remember, for power 1 we added only 1 for each factor. Here, if the power is j, we add 1, 2, 3, j minus 1, j partial fraction. And then you add all these things, do the same thing as before. But this is the form if you have a linear factor with power bigger than 1. Let's see this in practice. So here I have x plus 2 over x squared plus 2x plus 1. As you see, that degree of x plus 2 is less than degree of x squared plus 2x plus 1. This is very important. If degree is bigger than or equal, you should not start. You should not start the partial fraction decomposition. And then when you look at the denominator, this is x squared plus 2x plus 1, which is x plus 1 to the power 2. Okay, the power 2. Then the partial fraction decomposition form, at least I can start with form, yes. It must have, you see, the power is 2. We should have 2 here. One is for x plus 1 itself. The other one is x plus 1 to the power 2. If it was 3, we had to go 3 of those. And the first one has numerator constant, the second one numerator constant. This must be equal to x plus 2 over x squared plus 2x plus 1. And this is the key point. When you set it up correctly, the rest is just easy action to do. So what we do is find this. So here I will get a times x plus 1 plus b over x plus 1 squared. Note that I choose x plus 1 square as the common denominator. I didn't multiply then here in this case. So this is x squared plus 2x plus 1. This is x plus 2. From there you see that ax plus a plus b must be equal to x plus 2. And I can conclude from there that the coefficient of x in the left hand side is a, on the right hand side is 1. Coefficient of the constant is a plus b, and the constant is 2 on the right hand side. So from this and combine these two, 1 plus b must be equal to 2, and that means that b is equal to 1. So we found a is 1, b is 1. So that means that the decomposition we are looking for, let me just write it here in red, it's going to be 1 over x plus 1 plus 1 over x plus 1 squared. If you miss any of these ones and don't put it, you're going to be in trouble. You won't be able to equate both sides. Okay? There's another example here. I'd like to go over this one as well before we move, but I won't find the solution for this. I just fix the form of the partial fraction decomposition. So here the denominator is x to the power 4 minus 9x squared. And then I can factor out x squared. This will give us x squared minus 9. And the factorization is this famous part, yes. Now, we have two linear ones that have power 1. And we have one which has power 2. So for those ones, we put as we did before. So we will put x plus 3 there, x minus 3 there, and in the numerator we will put just constants. For just give me a second, I'll come back and put constant. But here, this is to the power 2. When a linear factor is power 2, you have to set 2 partial fractions for just that factor. One starts with has power 1 of that factor, which is x. The other one has power 2. So two partial fractions for these two factors and 2 partial fractions for this one. Okay, so then each one will have a constant in the numerator, and that is the form of partial fraction decomposition. I won't continue from here. I assume that you can do step by step everything here. Find the common denominator, which is x squared. You set always this guy to be your common denominator. It's also important. And then we'll find what is a, what is b, what is c, and d, and so on. Okay. But then you would say, what if I have a coefficient, a factor which is not linear? What should I do with that? So that has also, so far you learned what to do with the linear cases. the quadratic factors also can come in. So what about quadratic factors? Well, it will work very similar. So you first factor q out, and if you have ax squared plus bx plus c with power 1, so non-repeated factor, then for this we will assign one of these partial fractions which has quadratic denominator. So this will be there. Remember, for the quadratic, the numerator is ax plus b. Okay. How about if I have ax squared plus bx plus c to the power j, so repeated factor. So in that case, as we did for the linear one, we have to make j of these guys. One starts with the power 1 in the denominator, then power 2 in the denominator, and then you increase it until you get to the jth power. What about the numerators? Well, the numerator, when you have quadratic or powers of quadratic in the denominator, you must put ax plus b in the numerators. Well, now I will put some numbers there, just differentiate these ones. They don't need to be equal to each other. So I'll just, you can use different notations if you like. But the point is that you have to put something in the numerator, which is degree 1, and the coefficients are something that you have to find. And you see, this is the whole idea. So for each factor, depending if it is repeating or not, you assign one partial fraction or several partial fractions, and you add all these ones. That's the form of your partial fraction. Okay, let's see this one in some examples. Here, the denominator is x cubed plus x squared plus x. So if I factor out, it will be x squared plus x plus 1. And as you see, both of one is linear, one is quadratic. For each one, you will have one partial fraction. So for us, then x squared plus 5 over x cubed plus x squared plus x must have one partial fraction with x. The other one is x squared plus x plus 1. And remember, for the partial fractions with the linear term in the denominator, you have only constant. But for the quadratic, you should have something multiplied x plus constant. So I'll use a b x plus c. Okay, now you can do the work here. So let me just complete this one. I multiply x to x squared plus x plus 1. And I get a times x squared plus x plus 1 plus x times bx plus c. And while here, then we have x squared plus 5 equals to the coefficient of x squared, there is a plus b. The coefficient of x is a plus c. The coefficient of constant is just a itself. And right from there, now we can get three equations. Coefficient of x squared on the right hand side is a plus b, on the left hand side is 1. A plus c is the coefficient of x, on the left hand side it is 0, and a is the constant on the right hand side, in the left hand side is 5. So now you can go ahead and do this. So a is 5, then c must be negative 5, a is 5, then b must be negative 4. Okay, so then what we found is the partial fraction decomposition of this guy is a was what? A was 5 over x plus b is negative 5x plus negative 4x plus minus 5 plus c over x squared plus x plus 1, and that is what we have been looking for. Yes, so then you want to integrate, you integrate those ones one by one or so on. Let's do one more example here. Yes, so this time I have the denominator. This one I won't complete, I'll just write the denominator. Oh, the first thing to note here is that the degree of the numerator is 3, the degree of the denominator is 5. So we are good. Q is already, the denominator is already factored. And we have one linear factor with power 1. And we have one the quadratic factor with power 2. So for the linear one, we were going to have just one term because its power is 1. But for the quadratic, since the power is 2, we are going to have 2 of that. One with the power 1 and the other one power 2. In the numerator of the linear one, you have only one constant, but in the numerator of the terms which have quadratic in the denominator, you must make sure that you include degree 1 thing there. So this will be d x plus e. Okay, so that is the form of the partial fraction. Well, I can go ahead and complete that and set numerator equal to numerator, but I don't need anymore. Yes, because the rest is just similar things you have to do. But fixing the partial fraction decomposition form is the key point. Okay. So this way now you can set up every partial fraction decomposition that is given to you. And let me just finish this video with summary of what we learned here. That, okay, so when you're trying to find partial fraction decomposition, first make sure that the degree of the numerator is less than degree of the denominator. Otherwise, you should use the long division, and through that you turn your rational function to a polynomial and another rational function whose degree in the numerator is less than degree of the denominator. Then you decompose the denominator, and for each factor you put sums of some partial fractions. If you have linear non-repeating, you just put one term, so this must be ax plus b. Yes, so ax plus b, same ax plus b in the numerator constant. If it is quadratic non-repeating, you just add one partial fraction. If it is linear repeating, then for each power of that you have to add 1. So start from power 1, then 2, 3, and all of them in the numerator has constant. And the similar thing happens when you have a quadratic with power j. So in that case, for each power you add 1 partial fraction with quadratic powers in the denominator. Okay, and then, well, the rest is easy. Yes, so find the common denominator, set the denominators, well, such that the denominator become the same thing, and then set the numerators equal, and find equations for a's, b's, and then find all of those ones, and then you can use wherever you want. Okay, so this was then the rest of the work that we wanted to learn, and then do integration using these decompositions.